1-4 is measuring and classifying angles. Again, hopefully stuff that is review, but there might be a couple new things in here. Definitely important stuff that you're going to continue to use for the rest of the school year. This one. Okay, so angles, by definition, are formed by two rays that have the same endpoint. The rays are the sides of the angle. So when I name sides of an angle, I use the rays as the sides. The common endpoint where they meet is called the vertex of the angle. And when there is only one single angle, there are three ways to name it: by its vertex or using 3 points. So if you're looking at the diagram on the bottom, you've got one single angle there, okay? NP, ray NP would be one of the sides, and it's a ray because it's got the arrows at the end. Whether or not there are arrows there, the sides of an angle, because obviously sometimes it cuts off on a page or something like that, the sides of an angle are still rays. And then NO is your other ray, ray NO, okay? Notice that the arrow's over the letter that is where the arrow is, where it's supposed to be. The vertex is N. And so this is a big thing. If you only have one angle formed, so this vertex only shares one angle, then you can call this angle N, okay? You can also call this angle PNO or angle ONP, making sure that the vertex is in the middle there. So both of these times the vertex is in the middle. As soon as I divide this and I put another angle in there, now you can no longer use N. Because if I said angle N, how are you to know which of those three angles I'm looking for? Either the big angle or the two smaller ones. So only if that vertex is only used by one angle, there's only one there, then can you use one letter. If not, you have to use 3. All right, so if you have this diagram, if the vertex is shared, you must use 3 points. Give me all the angles that are in this diagram, and I'll give you a hint. There are 3. All right, give me one. Give me the name of one of the angles. Jivan. Angle ABC. That's the big one, right? ABC, which can also be called angle CBA, but those are the same angles, okay? You can call them either way, but those are the same angles. Give me another one. ABD, which is other's name would be what? DBA. And the last one? CBD or DBC, okay? You can use that little angle symbol. You can write the word angle out there too. It doesn't matter whichever one. If you list 3 letters, you're implying a plane, so be careful. You have to put the angle symbol or the word angle before it if you're talking about an angle. You cannot call this angle B. Questions? Okay, measuring angles. So a protractor is a tool that's used to measure an angle. Angles are measured in degrees, not in length. And there's 4 ways to classify an angle. Acute is if it falls between 0 and 90 degrees. God bless you. Right, it equals 90 degrees. Obtuse is between 90 and 180, and straight is 180. All right, example 1. Draw an angle, label it with your initials, and then measure it. And I'm going to show you a trick to measuring, okay? First, just draw it. So draw any sized angle, 180 or less than, and label it with your initials. If you have more than 3 initials, just pick 3 letters. Or if you have less than 3 initials, just pick 3 letters. Just don't duplicate them. So mine I can actually rotate, so I can line it up. Yours, your angle would have to be flat, okay? And notability, right? Because you can't like move it around like that. Okay, so you want to line the middle. Oh, I got to group this together. You want to line the middle of your little protractor, like where it crosses, right on the vertex. And you want your 0 line to be right on that 0 line, okay? And then wherever the line crosses through, you're going to have 2 numbers there, okay? So what's the difference? Like if you look specifically at mine, what are the 2 numbers that you're looking at? 50 and 130. Which of those makes sense? 50, why? Because this is definitely an acute angle, right? If it's less than the right angle, it's acute. So that's how you know which of those numbers to pick. Does that make sense? Yeah? Okay. Point. So it does not matter if I make that a teeny tiny protractor. If I zoom in on my angle or zoom out on my angle, the angle will always stay the same. So remember the other day when you were measuring like length of a segment and I said don't zoom in on it because it changes the size? Angles don't matter. I could zoom in on this as a huge this and then put the protractor on it. It will still be the same. I could zoom out on it, put the protractor on it. It will still be the same. So angle degrees won't matter. Does that make sense? Okay. All right. So I'm going to name my angle 3 ways. You're going to do the same thing. Because there's only one vertex, you can use the vertex as one of the names. So mine would be angle J. Then I can use angle MJC, and then I can use angle CJM. Vertex should be in the middle both times. Now the measure of my angle was 50 degrees. You're going to make sure you write the number, and then you're going to put the little degree symbol because you're not measuring it in inches or centimeters or anything like that. You're giving it degrees. And then this one I'm going to classify. Mine was acute. Did anybody draw an obtuse one? I feel like everybody picks acute. Okay. If you had drawn an obtuse or you were like dead on and got a 90-degree one, then it would have been right. If you'd drawn a straight line, because you could have, that's a straight one. Good? Easy stuff, right? Okay. All right. Postulate 3, which the number doesn't matter, it's the word of it that matters, is called the protractor postulate. And it just says, consider that line OB and point A on one side of line OB. That's what you've got there. You've got line OB, and then you've got a point on it. The rays of the form OA can be matched 1 to 1 with real numbers from 0 to 180. I don't know if you remember, but your ruler postulate just said that a coordinate can be matched with a name, right? So I can give a coordinate a value, and I can also give it a name. This is the exact same way. Every angle can be matched with real numbers that are measured. That's all this means, okay? So every angle can be given a value in degrees. That's what protractor postulate says. Okay, angle addition postulate. Remember we had segment addition postulate? And I said it's super important because you use it a bunch of times. Same goes for angle addition postulate. The segment said if I took a segment, broke it down into 2 parts, and added it together, I got the whole. The angle is exactly the same except for angles. If point B is in the interior of angle AOC, then angle AOB plus angle BOC equals angle AOC. So if I have an angle, right, like ABC, and then I have a point in the interior of it, so in between the 2 rays, and I draw a ray here, then I can say that AOB, which is this angle here, plus BOC, which is this angle here, add up to give me the whole thing.
Wait, why do you put that lowercase m?
That's measure. So lowercase m means measure, so I'm not just naming the object anymore, I'm talking about its value. So So as soon as you start talking about the value there, the degrees, then you're wanting to use the M. The M means measure. So if I take an angle, break it into two parts, I add it back together, I get the whole. That's angle addition postulate. The second part there says if angle JKL is a straight angle and point M is any point not on JL, then the measure of JKM plus the measure of MKL is 180 degrees. So I start with a straight line or straight angle, right? That's definitely a straight line. And I put any point not on JL. So we picked M and then drew a ray. So what this is telling you is that if that happens, if I take a straight angle and I divide it into two parts, the sum of those two parts have to be 180 degrees because a line has 180 degrees, right? So no matter where I split it at, I can take those two angles, I can add them together, set it equal to 180. Congruent angles. Remember, congruent means same size and shape. So we're saying that these two angles have the same measure. They're both angles and they both have the same measure. You will see little red angle arcs that mean congruent. So it will either be marked on your angle just like that. It will be written like this. The measure of angle A is equal to measure of angle B. Or it will be written like this. Angle A is congruent to angle B. They all mean the same thing. They all mean they have the same measure. But again, you can't just have two angles that look like they're the same. One of those three things have to be shown in order for you to know they're the same. All right, so here's some more congruency marks. Now we've got segment congruency marks, which are the little red dashes. We've got angle congruency marks, which are the red arcs. And if something is implied as a right angle, it must have that little right angle box. You cannot say something looks like a right angle unless it is marked or stated that it's 90 degrees. Everybody still good? Jose.
How are these congruent angles?
The top two, you mean?
Yeah.
So this angle and this angle, if they're marked like that, you would assume that they're equal. So put together like everything we just talked about. These three form a line, yes? What's true about those three? They would add up to what? 180. If this is 90, what do these two add up to? 90. If these two are the same, what are each of those measures? 45, 45. So you already know all that information from a shape, right? From a figure with some congruency marks. Okay, we had segment bisector, right? Now we've got angle bisector. A bisector of an angle is a ray that divides the angle into two congruent angles. You will know it is a bisector if you are given one of these four pieces of information. The first is that these are actually marked as two angles that are congruent. And they are adjacent, they're next to each other, which means if this splits that into two congruent parts, then that is an angle bisector, ray BD. The other way you'll see it is exactly as it's written. Ray BD is the angle bisector of angle ABC. So if that 20 and 20 were not there, you would at least know that they were equal. You may not know their measure, but you would know that they're equal. Or it will say ray BD bisects angle ABC. It means exactly the same thing. Or it will say angle ABD is equal to angle DBC. So if they are adjacent, which means next to, not overlapping, and they are equal, then that means that that middle ray is going to be your angle bisector. Yep.
Can it also be if it shows the congruent mark?
Yep. So if this was, instead of it said 20/20, it would look like that. That would be the other way. Yep. Questions? Okay, so this kind of puts a lot of the stuff together. I'm going to let you work through it, and then we'll go over it. All right, so number one says angle DEB, which is DEB, that angle there. What is another way to call that same angle? BED, okay. Oh. What else? What? BEC works. Actually, I can do one more. Oh, how did I do that? That's because that's from my other class. That's yours. Okay, what else can I call it? What's the shortest one if you're lazy? Connor. Huh? E you can't use because E is shared by more than one. 4. Angle 4 works. Okay? You could call it CEB, BEC, BED, DEB, or you can call it angle 4. Any of those work. Okay? All right, next one is CBE. CB, oops, let me do it in highlighter. CBE. All right, so give me some names to call that. EBC. There's one more. Angle 8. Okay, BEA. B, oops, I'm going to do a different color. BEA can be called AEB or angle 3. Okay. DAB can be called BAD or not 2. So this is the angle in which we're forming, right? So it could be angle 1. What else could it be? CAD or DAC. Either of those work. Does that make sense? Yeah? Okay. I know like you guys try to do the minimal work as possible sometimes, but for like I still highlight when I'm talking about an angle when I'm working. Like if I'm taking your chat, I'm taking like, doing the key or whatever it is, I still go letter by letter to highlight it because it's so easy to go the wrong ones. So be really, really careful when you're doing this stuff. Okay, so angle 7, and angle 7 is this angle, okay? Can be called what? ECA. ACE. BCD works, BCE works, ECB works, DCB works, right? All of those things work. There's lots of ones there. You just can't use, or can you use C this time? Yeah, you can use C because C is the only one that shares that vertex. Does that make sense? Yeah? Okay. Next one is 9. So 9 is here. Okay, what can I call 9? ABE. Reverse those letters. EBA. You cannot use B because B is shared by angle 9 and angle 8. Okay, now we've got some addition. So I'm adding these angles together. I'm using angle addition postulate basically. Okay, it says the next one, angle 1 plus angle 2. So if angle 1 is here and angle 2 is here, do I know they're congruent? No, but I know I'm adding them together to get one angle. What can I call that angle? Can't call it A because A could be this angle or this angle or this angle, right? So I can't use A. I have to use 3 letters. EAB works. EAC works. BAE works. CAE works. Okay, anything that gives me this full, complete angle. Good? No? No. So I know you got the 1 and 2 part. Yeah? Yeah. So if I take the 1 and 2, I need that whole thing. So now I need to describe this angle. A has to be in the middle, but I can use EAB, or I can use EAC, or I can use BAE, or I can use CAE, as long as it still describes the same angle. Okay, next one is 3 and 4. Say again. D. So it's this big one, right? 3 and 4 would be this big angle. What can I call that? DEA. AEC. AED. And then the reverse of all those letters, right? AED. CEA. Yeah. Okay, and then the last one is 5 and 6. 5 and 6 is here. What can I call that? That's that whole line. What's true about that? It's a straight angle. I already know the angle measurement there, which is what? 180 degrees. So I could do 180 degrees actually, right? If I wanted to know the measurement. But this is saying give me the measure with an angle name. So EDC works or CDE. Be really careful with these. There's a lot of letters thrown around, okay? Especially in a big shape like that.
So number 5, how can you only call it
C, because this is the only angle that it's not divided. That vertex only forms one angle. It only forms this angle, right? Where every other letter is divided. You see A is divided into 2 parts, so you can't use A. E is divided into 2 parts, so you can't use E. B was divided into 2 parts, you can't use B. And D is divided into 2 parts, you can't use D. C is the only one that's not divided. So it's the only one you can use that single letter for. Does that make sense? Questions overall? Okay, so let's talk book. There's 2 ways that you can access your book, and the first is an app, okay, that you're going to get from the App Store called e-textbooks.